Welcome to the New Industrialists. I'm here today with Adam Marsden, CRO of Crux OCM. Adam, it's great to have you on a show.
Thank you for having me.
Could you please tell us a little bit about your company?
Of course. So just like how autopilot is available in airplanes for the last 5 or 6 decades, what my company has developed is a framework that allows for closed-loop control to autonomously execute real-time commands for pipeline and other assets in the oil and gas space. What this allows us to do is ultimately to get increased throughput up to 7%, reduced energy costs up to 10%, as well as increasing asset lifespan and reliability of your pipeline assets.
This closed-loop autonomy, that's been a dream in the industry for many years. Is it becoming real now?
Yes. So specifically, what we're doing is for midstream, in oil and gas, that's an area that closed-loop autonomy has never really graced before. So we've taken it from other places, such as downstream or other industries. We've applied the patent, and now we're actually facilitating it real-time in pipelines. So it's something that they've been trying to do for 15, 20 years. They hook up simulators and that sort of stuff. But unfortunately, simulators don't have the AI capabilities or really just the compute powers to do it quick enough. So using the closed-loop mechanisms that we have at our disposal now, we're able to perform that and do it on behalf of folks.
When I talk to customers, there was always this disbelief every time I bring closed loop, and because basically it's autonomy, it's some level of autonomy. Yeah. Can you really do it?
Yeah, so one of the hardest things that we do with any customers, at least initially, is getting in and getting them past that initial barrier of, oh my gosh, can you do this? Yeah. And now that we're past that, A, can we do that? It's B, can we do this safely? And especially with all the tools at our disposal, are you able to perform this as safe as you can?
Safety what matters, or is it, can you do it at scale?
So both. So especially in our industry, in oil and gas, they go hand in hand. You can't have one without the other. So if you're not doing it safely, then they won't do it at scale. But ultimately, for the payoffs to be there, it needs to be a scalable solution that's employed.
So safety is a filter, scale is the proof point.
Correct.
So how do you do it at scale?
So ultimately, what we do is we've now developed something called the Industrial Automation Hub. And what that allows us to do is the unique thing that hasn't been conceptualized before is that we're able to take AI agents, the agentic agent infrastructure, pull in real-time data into that, and then build binaries through AI that are still pulled safely across into the client's environment. But ultimately, it's this industrial automation hub that does all the testing, all the training. It's your safe sandbox that you're able to do that in scale.
And what does scale mean for your customers? Is it a single pipe? Is it how do you even imagine the concept of scale with midstream?
So with the power cost problems that we have nowadays, power being extremely expensive, a client might come in and they say, hey, we want to solve our power cost issues at scale across all of our infrastructure, all the pipelines we have. Another client might say, hey, we have apportioned or prorated lines, so we don't think we can actually contractually get more through the systems. Well, with automation and with our technology, you actually can. So that's what they want to do, is they want to scale the solution to the problem that they have.
So you're really going after the mission critical component of their business, you are impacting the core of what they do.
Correct, 100%. So at the end of the day, what we're looking to do is we're not looking to replace the human or the person that's in that hot seat day in and day out,
operator,
12 hours a day. We're looking to augment them. So it's very similar to, instead of using an abacus, we now have Excel. Your pilots and planes have autopilot.
Your tooling is getting better.
Exactly.
But another thing that I would wonder about is, can you do this without replacing the existing systems? There's already infrastructure, there's automation, there's a SCADA sitting on that system, working. Can you do this without touching those systems, without replacing them?
Yes. So everything that we do is we're SCADA agnostic, whichever your provider you happen to have, we've architected it that way. We plug in right alongside that existing SCADA system, all of the existing field equipment, their PLCs, all of that. We know that it's a lot of Frankenpipe out there, which means that you have basically old pipe systems, new pipe systems are all merged and acquired together. Our system needs to be able to orchestrate and control all that. without there having to be a big lift and shift in order to do that control.
So give me more about it, because I'm still skeptical. There's a lot of data flowing through the infrastructure, data being collected, gathered, analyzed. They're probably running multiple data collection mechanisms. It's a lot of complexity there. How do you come on top of this and not mess this thing up?
So very similar to like an app on your phone, right? So an app interfaces with all of that data that's coming into your phone for whatever, wherever those data sources are. Ultimately, what that app's purpose is to do is whatever the problem is that you're having to solve it. So similarly for us, whether you have leak detection, you might have all sorts of other data from the field, safety, security, alerts. We ingest all that through SCADA so that we can take and make real-time executive decisions based off it.
Okay, you can kind of open it a little bit. Like, what is inside the bot? Is it a set of LLMs, some unique proprietary context that you give it? Like, how does it work?
So what we did for midstream specifically is we took a solution that's already been solved from downstream, so APC, Advanced Process Control. We ported that, and we patented it and ported it across into one of the tools within our toolbox. The way APC works is basically you can think of it as like a car. Once you get it up to speed, you're in 4th gear, 5th gear, whatever, it's a manual car, get it up to speed, APC will allow you to adjust the RPMs within any gear. The issue is that in pipeline space, or even downstream, upstream, there's a lot of transients that go on. So a lot of, starting and stopping of the pumps, the pipes, etc. That's the same as changing a gear in your car. What we've done is we've found a solution in a way that we are now patenting that does the discrete control. So it marries with the APC to do the transient or the discrete control in order to orchestrate optimization results in real time.
So very unique intelligence that you had to put on top of the data. You have to understand the framework, the pipelines, the data coming out of it, contextualize the data.
Correct.
Have you done all those steps yourself, or are you using other pieces of context, solutions, and logic from the ecosystem?
So we don't want to redevelop and redo the wheel, so to say. So there's a lot of other solutions that are out there in terms of, in the case of Microsoft, we leverage like their Azure, not only their Azure cloud, but some of their ingestion LLMs and such in order to really pull that data in, cleanse the data, QC it before it can get pulled and facilitated into our system. So there's also connectors when it comes to the data connectivity between SCADA and our system. So we could do that, or we could use an off-the-shelf solution, which is what we do.
And when you go and talk to customers, how do they take and interact with your solution and with the way you are framing it in context of their business? What's their reaction to it?
So initially, I'd say a couple years back, it was very much disbelief. It's like, no, you can't do this. We can't close the loop. Like it's impossible. We've tried it for the last 20 years. We've now gotten over that hump, thankfully. And now it's a matter of, okay, we have this problem set that we want to solve across these different pipelines. How fast can you do it? How fast can you do it safely? And more importantly, what's the end operator experience going to be for those folks? They're very, very sensitive to MOC, management of change. And what that means is that, just like any of us, when we get into a new car or when we first learned to ride a bike, it took some time for us to become acquainted with it. So they're super keen on, they want as little change as possible for their end community, their end operators, so that they can actually get up to speed in using the tool quickly.
Is it a business decision for them or a technical decision for them? Like, how do they evaluate it?
It's both. So there's definitely the business problem that we solve. So whether that be increasing throughput, reducing the energy costs, but ultimately it needs to go through the technical due diligence of how is this going to pass our cybersecurity risk matrix? How is this going to be architected and plugged in? Does this meet baseline requirements for hardware specs, et cetera? So it's both sides definitely have to come together.
And then there's this idea of the OT technologies and IT technologies. SCADA, you're clearly sitting on the OT side, where you are bringing this overlay that looks very much more like IT. Are you able to match these two worlds together with how you approach it?
That's definitely I'd say the paradigm shift that, one of the many paradigm shifts that our company has brought to the forefront. So with IT and OT, the marrying of those two, we know very well the OT space. We also know very well the IT space. To have them both come together and to have a closed loop solution like this that relies on the safety and the orchestration on one side, and the compliance and the technical bend and the other, that's really the proverbial needle that we have to thread.
And then I would think that you bring in the inner loop, the efficiency of the system itself, but you also bring in the outer loop. That's where the IT comes in, the scale comes in and play.
Yeah,
That's interesting. But you also have people involved in the process. You have the operators, I would assume, with very unique set of skills, and very difficult to find somebody who's able to run an operating room in a pipeline.
It is. So a lot of what the industry is facing, especially in the last decade or so, is it's that attrition that continues to happen as folks are getting older and they're retiring. So a lot of that historic baseline knowledge that people have developed over decades, that's leaving the industry. So having a solution like ours that comes in and autonomously is able to do the closed loop control while also overlaying some of that important historical knowledge from these folks that are leaving is the perfect coupling of helping bridge that gap. So
you must be interacting with a lot of operators, so you see their reactions. How do they feel about solutions that you bring to them?
So initially the operators are quite guarded. There's this, I'd say, innate fear, just like with a lot of AI technologies out there right now, that this is going to take my job. Ultimately, what we say is that regulatorily, just like airplanes have had autopilot for decades, this is a solution that really helps the pilot get up to speed faster, as well as helps them so that they're not so exhausted. But regulatorily, they're not going away. Like, when's the last time any of us have gotten into an aircraft without a pilot at the helm?
That's a great analogy, because yes, you're basically providing an autopilot to a pilot. The pilot is still the most important person on the plane, but doesn't mean that you will give them the tools to do their job better. I really like that framing.
Yeah, exactly.
It's fascinating. What's next for you?
So we've really put a lot of effort into our industrial automation hub. What that's going to allow us is to unlock the capability to take and through agentic AI, facilitate the creation of these binaries, or basically these solutions, for not just midstream oil and gas, but additional parts of oil and gas, and then the greater ecosystem as a whole. We have aspirations of building out beyond oil and gas, because ultimately at the end of the day, this architecture is allowing us to test faster, give clients the critical insights that they need, and get to the scale that they need more efficiently and quickly.
Yeah, I love it. It's a really good combination of bringing the inner loop, the automation, and the outer loop, the scale into the industry. Good luck. I wish you and the company the best, and thank you so much.
Yeah, thank you.